Part 1. At this very moment, while you watch this video, a silent traveler drifts through the darkness beyond our skies. A colossal comet, ancient beyond imagination, crossing the orbit of Earth. Its name is 3I Atlas, and it is unlike any comet humanity has ever encountered. Imagine a mountain of ice, dust, and primordial metals, roughly the size of Mount Elbrus, gliding through the void at cosmic speed. It was born long before our sun ever ignited, long before the Earth even existed, and it will continue its endless voyage long after both have vanished into cosmic dust. This is not simply a celestial object. It is a fragment of another star system, a messenger from the time before time. Tonight, we will follow its trail through the gravitational corridors of Mars, Venus, and Jupiter, tracing the path of a visitor that eluded even the most powerful telescopes on Earth. The mystery of 3I Atlas has captivated astronomers across the globe, not merely because of its scale or velocity, but because of the profound questions it poses. Where did it come from? Why did it skirt so close to the inner planets, yet hide from us behind the sun? And what secrets does it carry? Secrets perhaps older than the Milky Way itself. Our story begins with silence. For centuries, humanity has scanned the heavens, searching for patterns in the random glitter of the stars. Comets were once considered omens, heralds of change, fiery messengers from the gods. But today, science sees them as time capsules, frozen archives from the dawn of creation. And among those icy relics, none have challenged our understanding quite like this one. The discovery of 3I Atlas is not simply a new chapter in astronomy. It may be a preface to a much greater story, one that speaks not of our place in the cosmos, but of the cosmos's place within us. The first hints came from a faint, wandering light, a small anomaly detected by the Atlas survey system in early 2025. At first, it appeared to be an ordinary comet, yet its trajectory defied all expectations. It was moving too fast, far too fast to belong to our solar system. Its path was not an ellipse bound to the sun's gravity, but a hyperbola, a line of escape. Astronomers soon realized what they were seeing: a true interstellar visitor, the third ever recorded after Oumuamua and Borisov. But unlike them, 3I Atlas was enormous, dense, and impossibly ancient. Even so, its immense speed turned it into a phantom. Traveling at roughly 60 kilometers per second, it raced past the planetary orbits, like a stone skipping across the gravitational sea of our sun. Every attempt to capture its image was a race against time. Hubble's mirrors strained to focus on a blur of light, but what it saw was not a solid body, only a shimmering haze, a cloud of gas and dust that obscured the nucleus completely. The comet played hide-and-seek with the world's best observatories, vanishing behind the sun at the exact moment it drew nearest to Earth. For months, it remained invisible, concealed by the brilliance of our star. And yet, beneath that blinding veil, something extraordinary was happening. In those same moments, astronomers noticed subtle deviations in the comet's brightness. Irregular pulses, strange variations that could not be explained by rotation or sunlight. Some suggested outgassing jets, others proposed magnetic interaction with solar wind. But none of the models fit. It was as if 3I Atlas was alive, responding to the forces around it in ways no other comet ever had. Even more unsettling was the realization that this object's journey did not begin here. Its orbit traced back beyond the edges of our local bubble, beyond the faint traces of neighboring star systems. The calculations suggested it might have been traveling for billions of years, perhaps since the first generation of stars scattered their debris into the galactic void. It was a relic from another epoch, a fragment of a world that had long ceased to exist. And so the question became not just scientific, but existential. What stories are carved into the icy veins of such a wanderer? What histories lie frozen within its nucleus? Histories of other suns, other planets, perhaps even other forms of life. But there was something else, something even stranger. As astronomers attempted to model its trajectory, they found that 3I Atlas had passed through a remarkably specific corridor of the solar system, a narrow band intersecting the orbits of Venus, Mars, and Jupiter, as though its path had been carefully threaded through the gravitational web of our planets. Coincidence, perhaps, or something far deeper, the whisper of a cosmic pattern we do not yet comprehend. Still, the greatest mystery remained. Why did it hide? Why did it emerge only when the geometry of its orbit placed it directly behind the sun, shielding it from all human eyes? Was it mere chance, a celestial alignment dictated by physics? Or was it something more? A glimpse into the limits of our observation, a reminder of how much we still cannot see. Every scientist knows that the most profound discoveries begin not with certainty, but with wonder. Tonight we find ourselves standing at that edge again, looking not at what we know, but at what eludes us. The comet 3I Atlas is no longer just a dot of light in a telescope's field. It is a question, a challenge, and perhaps a message written in the oldest language of all, that of the stars themselves. What lies hidden within its blurred glow? What truth travels with it through the cold, eternal dark? The answers, as we shall see, are far stranger than anyone could have imagined. Part 2. When the first faint reflections of light from 3I Atlas reached the mirrors of the world's observatories, they carried with them more questions than answers. What at first appeared to be a familiar celestial body soon began to challenge the very foundation of cometary science. On July 21, 2025, the Hubble Space Telescope, that silent sentinel orbiting above Earth's atmosphere, turned its ancient eye toward the strange traveler. The decision to do so was not taken lightly. Every second of Hubble's observation time is booked years in advance, every minute calculated and argued over by scientists across the globe. But when data from ground-based telescopes revealed something extraordinary about this interstellar object, priorities shifted overnight. The Hubble team diverted its schedule, canceling other projects, and reoriented the telescope toward the coordinates of this anomaly. What it saw stunned everyone. Instead of the familiar, fan-shaped tail of dust and ionized gas that should extend away from the sun, a pattern dictated by radiation pressure and the solar wind, the images showed something impossible. A narrow jet, a concentrated filament of matter stretched directly toward the sun, as if the comet were defying every known physical law. The data were double-checked, then triple-checked, and the conclusion was inescapable. 3I Atlas was not behaving like any comet known to science. It was as though this fragment of alien material carried within it a secret, a mechanism or a composition that shielded it from the sun's radiation, or even interacted with it in ways that current models could not explain. The team immediately requested additional time from other observatories. On August 2nd, 2025, from the Teide Observatory in the Canary Islands, astronomers using a modest optical telescope collected 159 images with 50-second exposures each. Though the instrument's mirror was a fraction of Hubble's size, the results confirmed the impossible. A vast sunward jet, 6,000 kilometers long, emerging from the comet's nucleus and piercing the void like a luminous spear. It was a moment of convergence between humble technology and cosmic mystery, the world's most expensive and the simplest telescopes agreeing on a truth that defied reason. As the images were analyzed, teams across NASA, ESA, and independent research groups in Japan and Chile began to debate the physics behind this behavior. The most straightforward explanation, that the comet's tail was composed of massive particles unaffected by solar radiation, failed immediately. Large particles would not scatter light effectively enough to be visible, yet the jet was brilliant. Smaller particles, on the other hand, would have been swept away in the opposite direction by solar wind. There was no balance point in the equations, no combination of mass, charge, and composition that could explain what the telescopes were seeing. Something else was at work. Spectroscopic data provided even deeper intrigue. Within the gas cloud surrounding 3I Atlas, scientists detected traces of nickel, but curiously, almost no iron. Such a ratio had never been observed in any known comet, asteroid, or meteorite. In nature, nickel and iron are usually found together, their abundance linked by the processes that occur during stellar nucleosynthesis and planetary formation. Yet here was a body apparently refined, as if some process had separated the two elements, enriching the comet with nickel while stripping away the iron. On Earth, such refinement happens only in industrial conditions. In cosmic terms, it was as though one had discovered a fragment of a machine drifting through interstellar space. But that was not all. The comet's reflectivity patterns, its albedo, suggested a surface unlike that of ordinary comets, which are typically coated in dark carbon compounds and frozen water. Analysis showed an unusually high presence of carbon dioxide ice and a remarkably low water content, no more than 4%. This ratio contradicted all models of comet formation that assume water as a dominant component. The discovery implied that 3I Atlas had formed in an environment either far colder or chemically distinct from any region of our own solar system. Perhaps it originated in the outer layers of a protoplanetary disk around another star, or even in the remnants of a destroyed exoplanet, a frozen shard of a world long gone. Every observation deepened the riddle. Polarimetric studies, analyses of the light's polarization, revealed values beyond any known comet, indicating that the particles in its coma were scattering light in a way that defied established theories of reflection and refraction in cosmic dust. The polarization was negative at angles where it should have been positive, suggesting microstructures in the dust grains that might be hollow, porous, or even crystalline. The light signature was unlike anything catalogued before. 3I Atlas was not simply unusual, it was unique. And yet perhaps the most chilling discovery of all was its trajectory. As scientists refined their models, they realized that the comet's incoming direction was astonishingly close, within 9 degrees, to the same region of the sky from which the famous "wow" signal had been detected in 1977. The odds of such a coincidence were infinitesimal. Statistically, it should not have happened. Yet here was a fragment of alien matter, approaching from the same galactic coordinates as a mysterious signal that had once stirred the imagination of those searching for extraterrestrial intelligence. The connection, of course, might be purely geometric, but for the scientists who had devoted their lives to understanding the cosmos, it was impossible not to wonder. The research community erupted. Proposals flooded in for observing time on every major telescope, from the James Webb Space Telescope stationed beyond the Moon's orbit to the twin Keck observatories in Hawaii. Each hour of observation cost tens of thousands of dollars, yet the urgency outweighed the expense. Universities reallocated budgets, governments approved emergency grants, and private foundations poured funds into data analysis. By the end of the summer, the cumulative cost of studying 3I Atlas had surpassed the budget of an entire planetary mission. Still, the investment was justified. Scientists were witnessing a phenomenon that might never occur again in human history. Amid the rush for data, one truth became clear. Humanity's technology, though powerful, was still insufficient for a direct encounter. The comet's speed, 60 kilometers per second, made interception impossible. Even the fastest spacecraft, like NASA's Parker Solar Probe or SpaceX's Falcon Heavy-launched payloads, could not match a third of that velocity. To reach it, engineers would have needed to launch years before the comet's discovery, timing a rendezvous that current detection methods cannot predict. The gap between our scientific ambition and our technological capacity had never been so evident. Nevertheless, remote observation continued relentlessly. Spectrometers on the ground-based Gemini North telescope picked up subtle fluctuations in the emission lines, hinting at rotation or pulsation within the nucleus. The pattern was irregular, like the heartbeat of a dying star, and it suggested that the comet's surface might be fragmenting under solar heating. Yet strangely, no debris trail followed in its wake. The body seemed to repair itself or resist disintegration, its gravitational coherence far stronger than expected for a frozen conglomerate of ice and dust. Some models proposed a metallic or carbon-rich core, dense enough to withstand immense thermal stress. Others speculated about exotic materials, compounds formed under conditions of pressure and temperature unknown to us. Then came the turning point. As the comet moved outward, away from the sun, its brightness should have faded predictably, according to the standard inverse square law. Instead, its luminosity dipped, then briefly flared, producing a burst of radiation detectable in both optical and ultraviolet wavelengths. No comet had ever done this. It was as though 3I Atlas was releasing energy, not merely reflecting it, a burst akin to an internal reaction, or perhaps a venting of volatile gases stored deep within its core since the dawn of another star system. The data were ambiguous, but the implication was clear. We were observing an active, dynamic process inside a body that had been traveling alone through interstellar space for billions of years. By late September, when it had already crossed the orbit of Jupiter, 3I Atlas began to fade into the darkness. Its spectral signature weakened, and the once vivid jet collapsed into a faint thread of scattered dust. It was departing the solar system, accelerating on its outbound trajectory into the cold silence beyond Pluto. The last measurements from the James Webb Space Telescope, taken at infrared wavelengths, detected residual heat emissions inconsistent with simple cooling. Something was still happening within it, even as it drifted toward the eternal night. For many scientists, that was the most haunting realization. They had glimpsed an alien traveler only briefly, seen it flash across the solar system like a thought passing through a dream, and then vanish forever. Yet in those few months, it had rewritten everything we believed about comets, about interstellar matter, and perhaps even about the nature of cosmic evolution. The discovery of 3I Atlas proved that the universe is far more diverse, more intricate, and more unpredictable than our theories allow. And still, there was one final enigma. When all the data were compared, from the chemical spectra, the polarimetric readings, the dynamics of the jet, and the heat variations, patterns began to emerge. Subtle correlations between rotation period, gas composition, and luminosity fluctuations suggested an underlying order, almost as if the comet's behavior followed a sequence. Random natural processes rarely produce such coherence. Some dismissed it as a coincidence of overlapping cycles. Others, quietly, wondered if the object's structure might be more complex than any comet. Perhaps layered, perhaps engineered, perhaps something else entirely. In the end, no consensus was reached. The data, vast as they were, remained inconclusive. 3I Atlas had already passed beyond the range of detailed observation, leaving behind only archives of numbers, images, and unanswered questions. Yet those few months of pursuit had changed everything. The object had reminded humanity that our solar system is not an isolated island, but a crossroads, a place where travelers from distant stars may pass unannounced, leaving traces of their journeys in our skies. For the scientists who devoted sleepless nights to its study, the cost was irrelevant. The true currency of exploration is not money, but knowledge, and 3I Atlas paid in full. It taught us that the unknown is not empty. It is alive, dynamic, and waiting to be found again. And perhaps, somewhere out there, beyond the last reach of sunlight, that ancient traveler continues its voyage, carrying with it the silent memory of the worlds that once gave it birth and the curious eyes of a species that briefly caught its glow before it disappeared forever. Part 3. Every great discovery has a human story woven into its fabric. A story of those who dared to look beyond what was known, of the sleepless nights spent decoding faint signals from the void, and of the silent awe that follows when the universe answers in ways no one expects. The tale of 3I Atlas is not just the story of a comet, it is the story of humanity's restless curiosity, embodied by scientists, engineers, and dreamers scattered across the globe, united by a single purpose: to understand what lies beyond the fragile border of our solar system. Among them stands one name repeated in countless interviews and research papers: Dr. Ignacio Robles, astrophysicist and principal investigator of the Deep Survey Program for Interstellar Objects. His work, though technical and mathematical, is driven by a profound sense of wonder. For Robles, 3I Atlas was not merely an object of study, but a mirror reflecting our own insignificance and our endless desire to reach further. Robles began his journey as a young researcher fascinated by the early data on Oumuamua, the first known interstellar visitor. That event, brief and poorly captured, ignited a generation of scientists to rethink how humanity observes the skies. When the second such object, Comet Borisov, was detected, Robles was already leading a network of observatories designed to scan the heavens for anomalies in real time. His goal was simple, yet ambitious: to never again be caught unprepared by an interstellar traveler. And when the alert for 3I Atlas flashed across his monitors, he knew at once what it meant. It was as if a door had opened again, he would later say, a door that might not open for another 1,000,000 years. Within hours, coordination began across continents. Telescopes were repointed, and the chase was on. Yet even as the data poured in, Robles understood that this discovery carried something more than scientific importance. It touched on philosophy, on the ancient questions that have always haunted our species. Every image of the comet, every faint spectral line, seemed to whisper about origins, not only its own, but ours as well. If 3I Atlas was forged around another sun, in another system, then the materials that compose it once circled an alien world. Its atoms were born in the death throes of stars that shone long before the Milky Way's spiral arms took shape. To study it was to touch the prehistory of creation itself. The comet's chemical anomalies and physical impossibilities inspired a generation of young scientists. In universities and observatories, discussions about 3I Atlas became gateways into the new frontier of comparative astrophysics, the study of materials not native to our solar system. For decades, astronomers had speculated about the composition of other planetary systems, yet all their theories were based on indirect evidence: fluctuations in starlight, hints of atmospheric spectra, mathematical simulations. But this object, massive and tangible, was the first sample delivered by the universe itself, a visitor carrying the dust of another sun across the interstellar gulf. Its passage turned what had been speculation into data and what had been imagination into science. In many ways, the legacy of 3I Atlas mirrors the legacy of those who once launched the first telescopes into orbit or sent the first spacecraft to the outer planets. It reminded humanity of its shared purpose: to observe, to understand, and to preserve the fragile awareness that we exist within something vast and beautiful. In laboratories from Pasadena to Munich, teams of researchers still sift through the data gathered during those brief months of observation. Every few weeks, a new paper emerges, one reanalyzing the polarization data, another modeling the trajectory of the sunward jet, another exploring the possibility that the object's composition could be linked to a supernova remnant. None have yet reached a definitive conclusion, and perhaps that is the true gift of 3I Atlas. that it left us with questions more enduring than answers. But beyond the equations, beyond the instruments, lies the emotional resonance of the discovery. For those who watched it disappear into the darkness, there was a strange melancholy, as though saying farewell to a messenger whose message could not be fully read. The comet became a symbol of distance, of time, of all the wonders that pass through our lives unseen. Astronomers compared it to the brief flare of a cosmic lighthouse, illuminating for an instant the vastness of interstellar space. Its image, faint and grainy though it was, now hangs in classrooms and observatories, a reminder that we are part of something immense and ancient. Every generation needs its beacon, and for ours, 3I Atlas was that flickering light in the void. Meanwhile, the instruments of exploration continue to evolve. Missions like the upcoming European Space Agency's ERA probe and NASA's Europa Clipper, though not designed for this purpose, are expected to pass within several million kilometers of the region the comet once crossed. Even a trace detection, a faint residue of gas or dust left by its passage, would provide invaluable insight into its structure. Engineers have begun to discuss new detection systems capable of identifying interstellar visitors years before their arrival, giving humanity time to prepare, to design intercept missions that could one day fly alongside such travelers. The next encounter, they say, will not catch us unready. In this sense, 3I Atlas has already transformed the future of astronomy. It is the catalyst for a new generation of technology, a bridge between observation and exploration. There is poetry in the idea that an object born in another system billions of years ago could inspire the next leap in human exploration. Perhaps it is fitting that this fragment of alien ice, now speeding toward the unlit regions between the stars, continues to guide us from afar. Scientists have calculated that in another 100,000 years, 3I Atlas will leave the gravitational influence of our Sun entirely, entering interstellar space forever. It will travel among the stars, untouched, unseen, carrying within it the atoms of nickel, carbon dioxide, and cosmic dust that once puzzled a small species on a distant blue world. It will be our message in reverse, a record of our curiosity, written not in words but in the act of discovery itself. And as it fades beyond our reach, humanity is left with reflection. The story of 3I Atlas is a story about perspective, about how small our existence seems when measured against the lifespans of comets and galaxies, and yet how immense our minds are to even notice them. It teaches us that the unknown is not our enemy but our greatest companion. The same curiosity that built the pyramids, that painted the caves of Lascaux, that sent Voyager beyond the heliosphere, is the same force that turned our eyes toward this faint traveler and recognized in it a fragment of our own longing to explore. When the final reports were compiled, Dr. Robles wrote a single line in his conclusion that would later be quoted across scientific journals. The comet left us with silence, but within that silence, we heard the sound of the universe remembering itself. In those words lies the essence of all exploration, the belief that every mystery, no matter how distant, connects to the story of who we are. The instruments may fall silent, the images may fade, but the idea remains that somewhere out there, drifting among the stars, a small ancient traveler carries within it the echo of human wonder. And so, the chapter of 3I Atlas closes, not as an ending, but as a beginning. It marks the dawn of a new era in which interstellar visitors are no longer myths or fleeting anomalies, but the next frontier of discovery. It reminds us that even in the immensity of time and space, there is meaning in the act of looking up. Perhaps one day, when our descendants travel beyond the confines of the solar system, they will find themselves crossing the path of 3I Atlas once again. And when they do, they will remember